All right, it's Hack Week update time. I've been working on MAUI UI testing and I've got an update to share, a little bit more progress. So, one of the things I've been working on this week is figuring out what a nice flow is for actually creating the tests themselves with the framework. And there's a number of different approaches. REPL in the past was used for Xamarin UI test. One of the ones I saw recently was using YAML files where you would type in your commands and steps in a YAML format and they would be used to execute actual tests and actions. And it would watch the YAML file for changes, and every time you made a change and saved it, it would pick up that set of changes and it would rerun the tests. And it was kind of a neat way of iterating quickly on them. But then I had the thought, because I don't really love working with YAML, and parsing YAML in .NET isn't really the most fun thing either, that we have .NET Interactive Notebook. So I thought, well, let's give this a try and see if it's a good fit. And I think it actually really is. So we can specify NuGet packages in .NET Interactive, and I've got a local folder here with the package that I'm testing, which is Microsoft MAUI Automation Interactive. This package has the basic hosting driver API stuff that you would need just to write with a regular unit test, but it also brings in just a few extras like automatically adding using statements to the notebook so that you can do more with less code essentially. So if I go and run this code block, it's going to pull in the NuGet packages, install it. You'll see here that it's loading. We could add some custom extensions. So I've been playing around with like some custom commands that I'm not sure what we'll do there yet with that. It's maybe not the best fit, but it also loads this custom workbook file, which does the work of importing the using statements for like the Microsoft MAUI automation and automation driver namespaces, so that we can come down here and add a new code block and just start writing code against our driver. Now, I'm going to copy some code over and paste it in just to speed things up a little bit. But essentially, with this code now, we go ahead and we create a new app driver builder. And this is our main entry point into interacting with orchestrating and automating an app and doing UI testing. So this app driver builder, I give it a file name. In this case, it's an APK file that I've already made. I've already got a MAUI app that we want to automate and test with, and it exists at this location. Now I've added some code to make it a little bit more intelligent, and it goes and looks for the package ID inside that APK file, or the bundle ID if it's a Catalyst or an iOS app. So you don't have to specify it. You can specify it on the builder. It tries to infer everything that it can, and it also infers that it's an Android platform because it's an APK file. The other thing that I've got here is the device that I want to use. So you can see I'm just using an emulator name. I have this emulator created, and if I look at my ABD list, I'm just going to bring a terminal window in here to show this. I'm running this. I'm getting a list of which emulators I have on my local machine. In this case, I've got 2 of them. So I picked this one here, and I'm just specifying it by name. And that's going to make it go ahead and look for the emulator if it's running, and if it's not running, it'll start it and do all the work for us. So if we hit the play button here, this is going to start things up. It's going to start a new emulator up that just opened here. I'll drag it into view. And while that's loading up and doing its thing, let's add another code block here. And we can add our next bit of code. So once this is all running, the cool thing about notebooks is that each of these code blocks runs in context of itself. And so I can run these individually, and I can say, run everything above this code block and do it all that way. But the neat thing is here, once I've run this code block now, I've got a new driver session. This driver instance is actually still active, and I can start working with it, and I don't have to rerun this code block every single time. So this kind of gives us that power of iterating more quickly without doing the whole like test harness and everything over again from the start. So I added another code block down here intentionally separate from this one, because this one lets me actually install and start the app. And there's the start command does a couple of things. It checks to see if it's installed at all already. You can pass it a parameter to say I want to force it to be reinstalled even if it is. And you can also pass a parameter to tell it to clear the app state if that's important to you. But basically, other than that, it will launch the app after it verifies that it's installed, and installs it if it needs to. So let's run this code block, and we should see that app start right away here. And now we have this MAUI app up and running, and it looks like a simple login screen. And I'll show you the XAML for this here. The XAML is very simple. It's a label, a couple of entries, a button, and then we navigate after we log in to the main page. Now, the login, I've just done some simple stuff here. All I'm doing is like, if the username and password are empty, we could display an alert. This is my very secure login mechanism just to check the username and password are correct. And if that's all good, we push out to the next page. So I'm going to add another code block down here, and this is where we're going to start iterating on our actual test that we're trying to write. So in this case, we're going to write a test to log in. Now, I'll await my driver, and the driver has a number of methods. I can look for all of the elements or any of the elements of different set of predicates, and query is what we're using here. In this case, I want to look for the username field. So I'm going to say, give me the first element that matches the particular query I'm going to specify. And the query has a couple of shorthand APIs, so I can say by automation ID. And I know from the XAML that my automation ID in my MAUI control was set to entry username. And after I've got that element, I can say, go ahead and input some text on it, and the username was Xamarin. So if we do this, we'll actually see it start typing out the field, the text field there, and getting things set up. So the next thing we want to do is we want to actually go ahead and let's just duplicate this and enter the password. And so we have that really secure password of 1234. And so I'm going to run this again, and you'll see a couple things here. So first of all, we didn't clear out the field beforehand, right? So it just input the text. So I'm missing a command here that is clear the field, and we'll add that. And that's not a big deal, but it's not there yet. But this gives us the opportunity to do the whole restart our app state. So if I'm iterating on this test, maybe I want to include this code right in this block here, and I could just hit the test, and every time it reiterates from the start. But I kind of like working like this, where I only do it if I need to clear the state. So if I run this code block again, it restarts the app, and then I can go ahead down here and start over from that new blank app state. And now that's entering the things that I want it to enter, so I'm kind of happy with that. Next, let's do driver.first by, and then we can do automation ID again, but to show you some of the other stuff, we can say if it contains the text login. We could chain these together, right? We could say by type, so the type is a button, and then it would be then containing text. So we're starting to write this query, right? So it would find all of the buttons by type button, then it would filter them on any of those that it found containing the text. And finally, at the end here, it's wrapped up in the first. So it's going to give me the first of that whole series of filtering and querying that it finds. And after I've got that button, I can go ahead and tap it. And now that's going to give me the whole login sequence. So again, let's restart the app, get a clean blank slate, hit this test, Xamarin 1234, click the button, and now we're on to the next screen. So we've logged in, but we probably also want to make sure that we can assert that we've logged in, right? So usually with a UI test, we do some kind of trick with like, hey, if I see the element I'm expecting on the next page, or I don't see the one on the page that I'm leaving. So we could say driver.none if we wanted to, and then we could just use the automation ID from one of the controls that we used already that we know about, so that we can wait for that. Now, what happens here, what's kind of interesting is all of these different queries are automatically auto-waiting. I don't have a setting in here or an overload to change the default time yet, I don't think I put it in. But you could basically tell it to auto-wait none at all or change the default. But what it's going to do for you, it's going to keep checking that query over and over again at a reasonable interval of time, and you can change that default if you want as well. And after a while, it'll time out if it can't find it and throw an error. But that prevents you from having to write code that's like custom, written to wait for an element before you do something. The assumption here is that if you're wanting to find the entry that is for the username, you probably want us to just give you a little bit of wiggle room and wait for it and try to find it for a little bit before we assume that we can't. Because sometimes phones are slower, sometimes things take a little bit of time to happen after you do an action on them, etc. So we can await for none. So that means until the entry username has gone away. We could, again, just go straight to the next page and assume that we want to find, like, let's do the next step of this test. We want to click the next button, right? So we could say await driver.first by automation ID, and this one is button 1. And we might want to tap that button. And then after we've done that, we want to expect that that current counter has gone up. It's not 0 anymore. And so we can await driver.first, and we can say by type label, and then by containing text current count. And we don't maybe want to know yet, I guess, what the current count is. We could say that. So what we could do here is say, give me that label back that I found. And we can look at all the different properties that this label element has. And so we've got things like, is it visible? What's the type? What's the text on it? What's the frame and relative to the screen, to the window of the view itself? What else do we have here? We have the ID, we have the parent ID, we have its children, we have if it's enabled or not, we have if it's focused, we have the automation ID, we have all these different things that we can start to use from this element and start walking the tree with it. But usually it's pretty simple, the queries that we want to do. And so we can just say, hey, let's print the text of the counter that we found and do it that way. So let's try this all out. I don't know if I've tried this from start to finish yet, but hopefully it all works. So I've got my blank state again. I'm entering the username, the password, clicking the button, clicked the counter button, the click me button, changed the label, got the label back, and console right lined out the current count of 1, or the text from the label itself. So very early beginnings here. There's a lot that you can do with this. There's more things that need to be filled out, but shouldn't be that hard to do. There's things in the driver, like if we want to explore the driver API a little bit, we can call a backdoor method. And so like what this is going to be is you give it the fully qualified .NET type name, and then the method name. It's got to be a static method, and then any arguments that it would accept. So your static method should have a string array argument parameter, and you could call that method and return an array of strings back from it. And so this gives you a way to call into your app and do something. Let's say you want to code in just bypassing an entire flow through your app to get to a specific screen that you want to test. You could use it for this. What else do we have? We have, like, on Android, you can hit the back button. We can clear the app state. We can key press on the app. We can long press. We can push and pull files from the app. We can start and stop it. We can swipe within the app. We can tap. We can do all these things. Stuff like screenshots shouldn't be too hard to add. GPS coordinates, that kind of thing. So the idea here is that this driver kind of becomes this more robust set of APIs to help you automate your application and do what you need to do all of your testing. So this is where we've got to so far, keeping at it, hopefully filling out more of the driver APIs, adding new ones, making this more robust. It does work on Windows. It does work on iOS. Mac needs a little bit of help yet too. Some of the convenience interactions aren't available on Mac directly, so we have to figure out different ways to do them. But yeah, lots of progress. I think this is a good direction. I really like the .NET Interactive Notebook approach to it. It feels very comfortable, very smooth. Hope you like it.